where are you from, we're going to put that in the chat section. I think that's the way we're going to do it. So I think Megan's going to close the polling, or I'll just turn that off. And now we're going to move to the next slide, I think. Can you hear me, Greg? Okay, excellent. So I'm going to provide a little bit of background info. This is similar to what we did last week, and then I'm going to hand it over to Greg Dillon. Greg Dillon was the technical lead for this project, and he's going to talk a lot about where the data came from and how the data was used, and get into some of those details, and then provide you places where you can find even more details about the data. So if that's the kind of thing you're into, this is the place you want to be. Hopefully, we'll leave maybe 10 minutes at the end, and we can field some detailed questions. But Greg's the man with the detailed answers, and I'm just going to provide a little bit of background about what the project is. So I won't take very long doing that, and I'll move into that now, please, Greg. So the whole project, this website, came about because of the Consolidated Appropriation Acts of 2018. Congress asked the Forest Service, through the Secretary of Agriculture and the Chief of the Forest Service, to create a website that would provide data for communities to help understand their wildfire risk. What we've done is we produced a website with interactive data and maps, helping to help communities understand, explore, and hopefully reduce their wildfire risk. We've got nationwide maps and data, and we've used consistent methods and data all the way across. The product is searchable by your community, your county, or your state. We published this on April the 9th, just about a month ago, at wildfirerisk.org. We're primarily targeting the local leaders, local elected officials, land use planners, fire managers, fire collaboratives. It may be useful to folks at the state level. It may be useful to folks who are homeowners, but our primary audience is those community leaders. Next slide, please. So a couple of things about this site. So we used nationally consistent data and risk metrics. And here I'm going to take a little aside to make a plug for Landfire, because I'm the Forest Service business lead for the Landfire program as well. A lot of the data is based on a lot of the analysis is based on Landfire data. And really, Landfire is the only data set we have that's nationally consistent and has the depth and breadth we needed to do this kind of analysis for all 50 states. But the data that we used is Landfire 2014. So even the moment we release this data, it's a bit out of date. Landfire is working on an updated set of data for 2016. It's not fully released yet. And I suppose when that is released, we'll have an opportunity to update this. But we went for nationally consistent data, nationally consistent methods, nationally consistent metrics. It's available for all states, counties, and communities in all 50 states. It's grounded in the best available science, so particularly some of the work from the Rocky Mountain Research Station, including the Large Fire Simulator and the General Technical Report 315, which builds on the work of Scott, Thompson, and Calkin. And we hope, I mean, you'll be the judge of this, but we hope that it's easy to use and includes resources for action. However, there are some caveats I should warn you about, and that's on the right side. This is not a fine-scale product. It's better for comparing one community with another community rather than one neighborhood with a neighborhood, and it's really not appropriate to zoom into your house and see what the risk is there. It hasn't been locally calibrated. At the community level, at the state level, you have access to data sets that we don't at the national scale. And so we didn't have that opportunity to take all of that into account. It's not a predictive model. It's not like predictive services where they tell what the fire weather conditions are going to be over the next 3 months. And it doesn't include climate projections or talk about what the fire risk might be in 10 years. Instead, it's based on historic data, and it's more probabilistic rather than predictive. And the next one is probably the key point. It's not a replacement for other assessments that have been done. There are a lot of wildfire risk assessments out there that have been done at the regional, at local levels, at state levels, and they were all able to take in some of that local data. They were able to include different value assets. This one, we've only talked about structures, and Greg will fill you in on that. But this is sort of a supplement. It's a starting point for a conversation at the community level, and a discussion about what is our fire risk and how can we mitigate that. Next slide, please. This was a partner product. It was a partnership between the Forest Service, as we were directed to do this by Congress, but we quickly realized that we probably didn't have the resources we needed to process all of the data. So we partnered with Pyrologics, Joe Scott's company. They were able to do the massive lift of processing all of the data for all 50 states, literally tens of billions of pixels. And about the time they finished that or pulled that into conclusion around December of 2019, we realized we really didn't have the capacity to stand up a website that was going to service this data properly. So we partnered with Headwaters Economics. Headwaters Economics has a long history of distilling information for community use and partnering with the Forest Service and the federal government. And they have done an excellent job of putting together the website, as I'm sure you'll agree. Next slide, please. And this is where I'm going to hand it over to Greg to start to talk about the analysis and all of the parts that went into it. Over to you, Greg.
Okay, perfect. Thanks. Can folks hear me?
Yes, we got you.
Okay, great. Well, thanks for that introduction, Frank. Like he said, I've been the technical lead on this project in terms of kind of coordinating things from a science and technical end. But a lot of folks have contributed to this. So on that last slide, Frank showed you the team, which includes Headwaters Economics and Pyrologics. I wanted to just talk for a second about how the science and data team is actually quite a bit larger than that when you think about all the people that contributed. So, you know, we see this little diagram here with the overlapping circles of fire science and technology analysis and science application, which are related, but not always the same thing. Now, when it comes to the science background of this, being rooted in the Forest Service Research and Development Branch and part of the Rocky Mountain Research Station, I'm very fortunate to be able to lean on a lot of my coworkers who are scientists who've developed a lot of this risk assessment framework that we're using. And so the names that you see on the screen here are all people who we've leaned on in terms of reviewing earlier products or pulling from their work to develop what we're presenting here. And the names that touch on these circles here are people who were part of the core team for this project. So myself, I work for the Fire Modeling Institute at the Missoula Fire Lab, and we work in this realm of applied science and technology with respect to fire science. So it was a natural fit for me to work on this, as well as my coworker, Eva Caro. From the national perspective, we've got Jim Manakis and Frank Fay and Rick Stratton, all from the Washington office. Jim and Frank are the project co-leads. And then over here on the Forest Service research side, a bunch of folks who've given us input on the project, and also Forest Service and BLM folks who've given us input on the science and the technology aspects of it. So really a lot of people coming together. Now, as Frank said, to actually get the data development work done, we leaned really heavily on Pyrologics because they have a proven track record of just doing a great job of this type of fire analysis, fire modeling work. And so the names you see there are the folks with Pyrologics who directly worked on developing our data sets. So a little bit about our timeline for this project. It was really short when you think about the scope of what we were asked to do. So, you know, that bill was signed in 2018, in the spring of 2018. It took a number of months for things to come together and for the Forest Service and the Wildland Fire Leadership Council to provide direction on what they wanted us to develop. And so really, we met in the end of 2018 to start working that out, but it was February of 2019 before we really started doing the technical work. And I sat down with Joe Scott and we worked out the arrangement for Pyrologics to help us. And so Pyrologics helped us to develop the prototype for this. We chose the state of Washington through the early part of 2019, and by June of last year, we had a prototype. Then through the summer of last year, we had a prototype review period. So we sent that around to leadership, to folks kind of at the middle management and policy level, and then also in the science community to really get feedback from a lot of different angles. That resulted in science review in September, and then moving forward into developing our national products into 2020. And let's see. So our national deliverables, we were shooting for that April rollout to meet the deadline of the Omnibus Act, and the data were actually delivered in February. We took the time to get metadata and everything attached to them to get them ready to publish, and publish them in early April. So that's where we sit right now. And now I'm going to jump into the background of risk and how we incorporated the concepts of risk into this project. So if you visited our site, and from that opening poll, I see that many of you have at least visited it a little bit, you've seen this diagram, and this is how we are conceptualizing risk for this project. Risk is the product of hazard and vulnerability, and each of those is made up of some subcomponents. So hazard is made up of likelihood, which means the probability of wildfire burning in any specific location. So for us, that means on any specific pixel in our data set. And then we have an estimate of wildfire intensity. So if a fire occurs, what is the likely intensity that we might encounter? And both of those come from fire behavior modeling. On the vulnerability side, exposure is simply the overlap between where something of value, in this case with this project, we're dealing with home locations, where that overlaps with the components of wildfire hazard. And then susceptibility has to do with the likelihood that a home, in this case, will be damaged by wildfire if it encounters it. So we'll dive into each of those a little bit more. So I wanted to point out, though, that those concepts, we didn't just pull those out of thin air. We're pulling those from about 15 years worth now of literature on risk with respect to wildfire. And so the papers you see here are some of the foundation of that. Mark Finney published this 2005 paper on the left that really sort of took risk equations from other disciplines and framed it in the context of wildfire. That funneled into the 2010 Cohesive Strategy Science Report, which really kind of set these types of risk assessments and analyses as a foundation for doing strategic fire planning. And then the document on the right is that Forest Service GTR 315, which really provides a roadmap for how to do a spatial quantitative wildfire risk assessment. Now, since those were published, a lot of examples have come out in scientific literature of case studies, new concepts that have continued to emerge, definitions of terminology solidifying, and these are being applied at forest scales, at regional scales, watershed scales. And that's kind of the key point of this, is this risk assessment approach that we're building this project on is scalable from the watershed scale all the way up to national. So here, obviously, we're dealing with a national level assessment. So getting a little bit into those components that I just talked about a second ago. So the likelihood and intensity pieces that make up hazard. As I said a second ago, we get those from fire behavior modeling. And to do that fire behavior modeling, we need a suite of spatial data that is consistent across our entire domain. So in this case, the entire United States. That consists of data on fuels, topography, weather, and fire occurrence. And I'll talk a little bit about where we pulled those data sources from. So Frank gave a plug a second ago for land fire. For this project, we used fuels and topography data from the Landfire 2014 release, so version 1.4. At the time that we were getting into this, those were, and still are, really the only or the most comprehensive and up-to-date data set available for the entire United States. The Landfire remap that will be up to 2016 conditions is almost complete for the country, and when that is out, we'll rerun the fire behavior modeling and hopefully at some point in the future update our data sets. But this is an important point and a question that we get a lot. Our data reflect a 2014 landscape in terms of the fuels conditions on the ground. So moving forward in terms of weather data, we pull that from energy release component, ERC, which is downscaled from gridded weather data sets from Matt Jolly at the Rocky Mountain Research Station from about the last 20 years. We also pull wind information from RAWS stations, remote automated weather station data, one of those in each of 136 modeling regions across the country that are called pyromes. And then in terms of the fire occurrence data, we pull that from fairly comprehensive, really the most comprehensive available data set that's out there for that. It's a point fire occurrence database that's developed by Karen Short at the Rocky Mountain Research Station. And for this, it covered records from 1992 to 2015. So those are the data that our products are built upon. The fire behavior modeling that we use is the FSIM, or Large Fire Simulator model, developed by Mark Finney and others at the Missoula Fire Lab, and now implemented on a national scale using those pyromes as modeling regions. It's been delivered a couple times now. Karen Short is the primary scientist working on that, and again, Pyrologics is involved with that effort. And so we built this on the FSIM modeling outputs that came from the Landfire 2014 data set, and those are available as 270 meter raster data sets available for download across the country as well. All right, so that gives you an idea of what our data is and what the fire modeling is. I just want to show you then to take those 270 meter pixel data sets that are available nationally and make them applicable at the community scale, which was our charge for this project. We had to do some spatial processing. So here you see the 270 meter data sets for 2 example communities from the state of Washington. So Chelan is a smaller community, it's on the left there, and the city of Spokane and surrounding area is on the right. And so you can see the scales for reference. We have 2 miles here and 10 miles here. And you can see that at both of those scales, the 270 meter pixel is very blocky and less than desirable for interpreting this data at a community scale. The other thing that is immediately noticeable in this is I've got aerial photography imagery displayed beneath this, and anywhere that you can see through to that base map means that the Landfire project mapped that as a non-burnable fuel. So in these cases, it's most likely mapped as some type of developed environment, and those get assigned non-burnable in the fuel model raster, which means that in our fire behavior modeling, they don't get any estimates of burn probability or intensity or the characteristics that we need information about. So what Pyrologics did is they developed a way to take those data sets, run them through some focal analysis, apply some windows and some smoothing to spread those values into the community some distance, and also at the same time bring the pixel size down to 30 meters. So I'm going to switch now from the 270 meter view to a 30 meter view. And so after the processing that was done for this project, this is what the data set looks like. This is burn probability that we're looking at. And you can see now that in a smaller community like Chelan, we have a burn probability modeled for every place, every pixel within that landscape. For a city the size of Spokane, what we see is that by spreading it into the community, we've extended a burn probability. In our case, we used 1 mile as our distance, 1 mile into that community that is rapidly declining as you go away from the natural vegetation. So it's giving us some possibility of fire in there, but it's declining as you move away from the natural vegetation. And then you still end up with an urban core where you're far enough from the natural vegetation that you are not exposed to wildfire. And so, using that term exposed to wildfire, what that process allows us to do is map exposure types. So what we have here is a product that's on our website that depicts places with burnable fuels mapped by Landfire as being directly exposed. So the dots in these images are Microsoft building footprints. And so any of those structures that are in the pink areas would be directly exposed to wildfire if a fire occurred, which means they might experience direct flame contact. The places that are shown in orange are areas where we spread those fire behavior characteristics, and they might not be in direct contact with the flames, but they still likely could be exposed to wildfire through embers, home-to-home ignition, and other indirect sources. So we've covered likelihood and intensity. I just showed those dots as structure locations or home locations. So the spatial intersection of those two things gives us wildfire exposure. And that is essential as well in terms of thinking about risk. And so for home locations in this project, we so far have used the Landscan USA population database that comes from Oak Ridge National Labs. We used the 2017 vintage of that and converted it to a 30-meter resolution housing unit density raster. And so that tells us where homes exist, and we can overlay that with our likelihood and intensity and find where we have areas of exposure. So what about susceptibility? We've covered the other three components of risk here. Susceptibility from a national scale perspective is tricky because it's something that is going to vary from house to house. And obviously we don't have the ability to do that in a national scale effort. So I'm going to read part of this definition. This is from one of our layers on the website, Risk to Homes. And it says that that data set integrates likelihood and intensity from simulation modeling. Those two risk components represent wildfire hazard, like we've talked about. Then this is the important part with susceptibility. To translate this into terms of terms specific to the effect of fire on homes, wildfire risk to communities uses a generalized concept of susceptibility for all homes. And so that generalized concept of susceptibility is what we call a response function. So I wanted to just talk about that for a second because it's key to how we talk about risk. So a response function looks like this, and basically what it is in the fire modeling, we get estimates of intensity in these 6 flame length classes, ranging from 0 to 2 foot flames up to greater than 12 foot flames. And for each of those, what we have to do is just make this broad generalization that if a home experiences fire of that intensity, roughly what percentage of damage is that home going to experience? And so here is the response function that we used for those low flame lengths, just a 25% damage. At the highest flame lengths, 100% damage, so total loss to that structure. Now, obviously, this is a gross generalization, and we know that, but to be able to map the concept of risk at the national scale, we needed to do this. And I did, just to make that point a little bit stronger, I know and I will recognize that there are cases where the assumptions in our response function just don't hold. So these pictures show examples of that from Jack Cohen's work, where, you know, on the left we have a case of clearly a place that had low flame lengths, a surface fire, because the tree canopy is still intact, and yet we have total home loss. On the other side, we have a forest canopy that's completely burned away, so probably high intensity flames, and a home that's still standing because they took mitigation action. So we recognize that actual susceptibility varies from home to home, and we don't reflect in this project the mitigation efforts that have been done on any specific structure. So it's more meant to be a relative landscape-wide measure of risk. All right, so then the important question that always comes up, what is a community? How did we define that as part of this project? So for us, community came directly from the US Census Bureau 2018 Places dataset. This is something that you can go online and download. It's a Polygon dataset, and it includes all legally bounded incorporated places like cities and towns. It also includes unincorporated census designated places, or CDPs. And so for the United States, including Alaska and Hawaii, we have a total of just over 29,000 of these that you can search information for on our website. We also made it searchable for counties and states. And so again, counties, we use Census Bureau data, and we have over 3,000 of those that are searchable, and then all 50 states, as well as the District of Columbia. All right, so that gives you information about the background of wildfire risk and the science that went into it. I'm going to get into now the data sets that we have. So those of you that have visited the website, you've seen that we have interactive web pages for 3 map products: risk to homes, wildfire likelihood, and exposure. And then we also have information about vulnerable populations not associated with the map. For download, we actually have 8 raster data sets, and I'll show those to you here soon. But we have the first 3 that are on the website, and then also some that represent intensity, conditional risk, and then wildfire hazard potential, which is a product that we've been producing for several years now, and I'll show an example in a few minutes. Okay, so at this point, I'm going to break out of my PowerPoint slides, and I'm going to go to the website so we can take a look. Let's see. Here we go. All right, so hopefully that screen just switched over and you guys are now looking at the Wildfire Risk Communities website. I'm going to go to this tab, which shows the home page. And when you visit our website, this is what you will see. This is the home page that has the 3 main pathways for navigating the site: understand risk, explore risk, and reduce risk. And so we're going to spend some time looking at the Explore. The Understand page basically goes through a lot of what I just talked about, the fundamentals and components of risk. And the Reduce Risk is filled with resources that a homeowner or a community can look at to find ways to reduce their risk. But we're going to get into the Explore section. And in fact, when that comes up, you get a search box where you can type in the name of your community. In this case, I pre-searched for Jefferson County, Colorado. So I typed that in, I selected Jefferson County from the list, and this is the map that opens up. And it comes up on our Risk to Homes map view. So I read you a little bit of the definition for that product a minute ago. This does incorporate most of the elements of risk that we just talked about. It incorporates likelihood and intensity. And since we searched on a county here, what we're looking at in the chart on the left are counties within the state of Colorado compared against each other on those axes of likelihood across the bottom, and in this case, consequence, which uses the response function that we looked at times the intensity. So the vertical axis is taking into account intensity. The horizontal axis is taking into account likelihood, and we can see how each county falls with respect to both of those. And here is Jefferson County. We can hover and see that it's at the 92nd percentile across the state of Colorado in terms of its wildfire risk to homes. Now, one important thing about these maps is the map is showing values for every pixel across the landscape, because we wanted people to be able to evaluate wildfire risk to a home in a place, whether one currently exists there or not. The reason for that is, let's say you're a land use planner and you're evaluating a place where somebody wants to build a subdivision. There aren't homes there, and so if we mapped risk just where homes exist now, you wouldn't know what the risk might be in that place. This map allows you to evaluate that. But it is important to consider when you look at these maps that the summary data on the left in the chart is really just for the populated areas within these places. And so we, to do these summaries, overlaid our housing unit density raster with the map that you're looking at here to just summarize the data where population exists. So this is our risk to homes map. I'm going to show, let's see, yep. The terms over here are clickable, so you can get definitions. So if we wanted to know what risk to homes mean, I can click on that, and I get a short definition here. I can then click on the glossary if I want to read more, and I'm going to see a full expanded definition of what that means. And you can see even we get a little diagram that shows us the parts of risk, the components of risk that are represented in this map. I'm going to switch over to our exposure type view at this point. Okay, so you saw an example of this for Chelan and Spokane, Washington just a minute ago. Here we are for the community of Jefferson County. Now this is a map that as I zoom out, it really kind of loses a lot of meaning because you just see that pink color everywhere where there's natural vegetation. Again, just like the previous map, this is showing a value for every pixel across the landscape, regardless of whether there's currently a home there or not. Saying if a home were to be on any pixel here, this is the exposure type we'd expect it to have. So this map is really most useful when you zoom in locally. And you can see with this website, as I zoom in, I get a little bit of reference information, and then I reach a point where I can no longer zoom in any further. And that's, again, to that point that Frank made earlier, this is really intended to be a kind of a broad landscape level view and not something where you zoom into your specific parcel. But this tells us that breakdown of indirect versus direct versus not exposed within the populated parts of the community we've searched for. The third map view is wildfire likelihood, and so this is that burn probability, the probability of any specific pixel experiencing fire in a given year. This is not a prediction of this year or next year, as Frank said. It's probabilistic, meant for strategic, more of a long-term strategic planning view. But with this one, again, you can zoom out to get a regional perspective, and this does give you, it's a little bit more relevant at that regional scale. Another important thing to note about our maps, and I mentioned this in last week's webinar, when you search for a county or a community, you reach a point where you can't zoom out any further either, and that's intentional because we're looking at data relative to our state. If I click on Colorado in my breadcrumb trail up there, now I'm looking at data for the state of Colorado compared to other states across the country. And at that point, if I want to, I can zoom out and I can look at the entire country. See that we've got the lower 48 there, we've got Alaska up here, and we've got Hawaii down here, all filled in with data. All right, so that's, let's see, that's what I wanted to highlight there. On any of these pages, when you're viewing the map interactively, there's a download button, and your Zoom video window may be over this, but there is a download button up here in the black menu bar. You can move that video out of the way if you need to. And if I click on the download button, it takes you to this page. Tells you that we've got GIS data. We have tabular spreadsheets that summarize the data by state, county, and community. We have some national map graphics that you can download as PDFs if you'd like. And then a paper that describes all the methods that I'm talking about today. Any of these buttons that say get data actually take you to the same page, which is this US Forest Service Research Data Archive site. And this is our data publication for this project. On this page, you can read about what's included in the data publication, the 8 different raster layers. And then you can access metadata files, a file index that lists the contents of all these download files. The tabular summaries and the methods document are all bundled into one support file zip that you can download. And then the raster data are bundled by state, because at 30 meters, they're quite large. You can see the download sizes can get pretty large, but you can download states here. If you need the entire country, that is available upon request as well. And then I just wanted to show very briefly what the methods document looks like. You know, a lot of what I'm talking about today is kind of an overview level. If you really want to know the details of the spatial processing, download the support file document and you'll get this. I'll just show the table of contents real quickly. You know, we provide some of the same background I'm talking about today, talk about the details of our input data sets, and then how we did the spatial processing for that smoothing and spreading of values into the community, and details about the raster data sets and the tabular summaries. So that is available for anybody who wants more information. All right, I'm going to switch back over, let's see, to the presentation. There we go. And just show some examples of these 8 raster layers that are available in the download. So this is our wildfire likelihood, also known as burn probability. So it does represent the annual probability of fire on any pixel. And you can see that represented by the legend on this in terms of a 1 in X chance of fire in any given year. So any place with this sort of darkest blue color has less than a 1 in 10,000 chance of fire in any given year. Now, that is at the pixel level, and so don't let those tiny numbers deceive you. It's still possible for fire to occur there, and those numbers can be aggregated across larger areas, but those are the areas with the lowest probability of fire. And so this data set, you know, you can explore, download and explore at your convenience. As with all of these data layers, as I mentioned earlier, they're from Landfire 2014, so they're representing fuel conditions as of circa 2015. They were originally modeled at the national scale at 270 meter resolution, and we have used that process that we're calling a raster upsampling process to convert them to the 30 meter versions, as I showed a little while ago. All right, this is one of our intensity products, conditional flame length. And so this is the most likely flame length on any pixel if a fire occurs. It's an average measure of wildfire intensity out of the fire behavior modeling. And for those familiar with fire metrics, the fire behavior model actually gives us mean fire intensity, which is in like watts per meter squared. We convert that over to flame length to make it more relatable. And so you get these standard classes of flame length. Yeah, I think that's all I'll say about that, but it's an average intensity measure that you can get in the download. We then take that and produce a couple offshoots that are useful in terms of interpreting kind of meaningful thresholds of intensity. So this one is what we call the flame length exceedance probability, or FLEP for short, representing the chance of 4 feet flames or greater. So this is known as FLEP4. And that's significant because 4 feet is often considered to be the limit of manual control of wildfire. So that the degree, or the point at which you know, suppression by a hand crew is no longer effective. And so this gives you the chance of seeing greater than a 4-foot flame on any pixel if a fire occurs. Similarly, we have the FLEP8 data set. So this, again, is significant because 8 feet is often considered to be the limit of mechanical control with heavy machinery and things like that. And so this gives you that chance of seeing greater than an 8-foot flame on any pixel if you have a fire. Here is the exposure type that we saw a minute ago. And as I pointed out, at the state level, it's really not that useful. And I also would argue that it's not that useful at the national scale as well. It just looks like a sea of red or pink. As I mentioned, it's based on where fuels are mapped as burnable versus non-burnable by land fire. And that the indirectly exposed places are within 1 mile of contiguous burnable fuels, areas of roughly 1,200 acres or greater. So here's a close-in zoom like we saw a minute ago, and this is where wildfire exposure type really, I think, shines. And so this is where I think it can be really useful at that local scale to help with homeowners understanding the types of mitigations that they might need to take on. So this is an example for where I live in Missoula, Montana. But even beyond that, this is how it's represented in the website. But if you download those data sets, you'll see that it's actually presented as the indirect exposure is presented as continuous decimal values between 0 and 1. And what's useful about that is that you can break those into classes if you want to. So here for Missoula, I've just broken them into 5 classes that show you a range of, you know, the areas that are maybe indirectly exposed but could be exposed by, say, very short range spotting from the natural fuels, maybe short range, moderate range in the sort of light blue, and longer range spotting downtown Missoula. For any of you know, Missoula is down here, and you know, that's unlikely to be exposed to wildfire, but it's possible with long range spotting. So breaking down that exposure type map at the local scale might be very useful, and that's something you can do when you download the data. I showed you our risk to homes map, and really the building blocks of that are the burn probability, which we've already seen, and then this map, which is the conditional risk to potential structures. I know that name is a little bit of a mouthful, but it represents the wildfire consequences if a fire occurs, and specifically the consequences to a home, because we're using, as I talked about earlier, that response function for damage to a home. And so the reason that we're saying potential structures is that this map assumes that there's a home on every pixel across the landscape. And by doing that, then we're applying that response function to every pixel across the landscape with our estimates of intensity and probability out of the fire behavior modeling. And we get this conditional risk to potential structures, or wildfire consequence. And then lastly, we have the risk to homes as a product of burn probability and that previous map. And so with this one, it's asking the question, what would the relative risk to a house be if one existed here? And it asks that for every pixel. For those of you that might have worked with risk assessments before, this is analogous to expected net value change, which is a common metric of risk from the GTR 315 that I mentioned earlier. We do have one final product as well. I mentioned this earlier, the Wildfire Hazard Potential Map. And this is one that I've produced along with Frank and Jim Manakis for the last about 10 years almost. And we have produced it as a 270-meter national raster. Because we had the 30-meter data sets available for this project, we went ahead and calculated it at 30 meters. So this is really useful for fuel treatment prioritization. It quantifies the relative potential for wildfire that might be difficult to control. And it incorporates some elements that make it really focused towards fuel treatments in forested fuels. And I won't get into too much detail about that. You can read about it, or I'm happy to answer questions later. But less applicable to homes, more applicable to forest fuel mitigation work. And yeah, as the note down here says, this was previously published in 2012, 14, and 18 based on the 270 meter data. And I will soon actually be publishing a 2020 version of the 270 meter data that will look very much like this, but at 270. All right, so that's a lot about our current products. I'm just going to take a couple minutes to talk about some future enhancements in the queue, and then I'm going to open it up for questions. So I showed you this timeline a little while ago. This is where we left off with publication of our current data sets. We are still working hard towards a set of additions and enhancements. And so we're hoping that by August or maybe September, we'll have a second round of data products to add to what we currently have. So this is what we saw already in terms of the list of available products. In that August or September release, we're looking at actually publishing our housing unit density raster that I've talked about. The reason we haven't put it out yet is actually we have been working on refining the process for mapping housing unit density beyond just using the land scan data. We're actually also using the Microsoft building footprint data. We're using Census Bureau data to try and get the most accurate numbers that we possibly can for that housing unit density product. And then once we have that, we can overlay that with our risk to homes and some of the other layers to actually map risk in the places that houses just exist. So that will be available for people that want it. And then at some later date, we are also working toward some wildfire transmission data sets that show the source areas for wildfire risk and places where fires could start and impact communities. Very similar to a lot of the work that Alan Egger has already put out, if any of you are familiar with his work. And these are just some map examples of what those look like. So here's that housing unit density raster from our prototype effort for the state of Washington. Then once we overlay that with the risk, we can map expected annual housing unit exposure here and housing unit risk. And then this is an example of what that source map could look like, mapping places where fires could start and most likely have an impact on communities. So those kinds of products could help with, particularly with fuel treatment planning. And then one last enhancement that we're working toward is expanding our definition of community. And so right now, as I mentioned earlier, we define communities by the polygons from the Census Bureau places data set. So in this slide, the crosshatched area represents the actual community boundary for the city of Wenatchee, Washington. But we know that there is a lot of population outside of those incorporated boundaries that is still at risk. And in our current summaries, those wouldn't be included. Say homes that are just outside that Wenatchee boundary would not be included in the summary for Wenatchee. Now they would be in the summary for the county and the state, but not for that community. Well, Alan Egger, who I've mentioned already, he and his colleagues have come up with this really innovative way to map zones around communities using a travel time algorithm. And it considers the community itself to be the core, and then it looks at populated places within a maximum drive time, and they use road networks and speeds and a maximum drive time of 45 minutes to associate homes with the nearest population core or community core. And so what you see here in the bold outline is the zone defined with that algorithm for the community of Wenatchee. And so we would be able to summarize data, not just for the defined community, but also for the community zone for every community across the country. And that's, we're working toward that. That's actually hopefully coming soon. And that concludes what I wanted to present to you. And so at this time, we can open it up. I've seen the chat window moving, but I haven't been able to read while I'm talking. So we can,
well done, Greg. There's a lot of questions. I don't know, maybe Kelly, Megan, and I can we've been trying to answer them as they go, but I think we're going to need you to expound on some of these because a few of them got a little technical. And
Real quick
maybe we
before
can
we
tag
get
team.
a couple of housekeeping things before we get started. Some people have asked if we can host the PDF of this talk and last week's talk somewhere. So we're going to put those on the Wildfire Risk to Communities website. So just to answer that question, I'm going to launch a poll really quick to help understand our evaluation. If you want to take that poll and minimize it and don't worry about it, and for 10 more minutes don't worry about it, but I just want to have it up there so folks can take it as they want, and then I'm going to hand it over to Frank and Kelly and you guys can tag team your questions.
Hey Greg, I'm going to try to interpret some of the questions. I'll do one and then let Kelly do one and we'll just go back and forth.
Sounds
we
good.
get expansion on all of what we saw. I saw a question about did we use Flam Map? And I answered as no, I don't think we used Flam Map. But maybe you could expand and talk about the pros and cons of Flam Map versus FS Pro versus FSIM. Briefly.
Sure, yeah. We used FSIM exclusively for this project. And so what FSIM gives you, it's an ensemble model approach, which basically looks at the weather patterns in the data that we're ingesting, so the last 20 years or so, and develops statistically probable weather streams. And so we're simulating tens of thousands of iterations. It's a Monte Carlo type simulation, and it's going to simulate every possible type of year that you might imagine, your wet and cool year, your hot and dry year, and then it's going to average all that stuff together in the aggregate probability and intensity data. And so that's what we're looking at here. Flam Map is often used in a localized assessment because what you can do with that is give it a specific weather scenario. And often people will use Flam Map to define kind of the problem fire scenario, which is like the 95th or 97th percentile ERC, and kind of what you would consider, like for example, Southern California, Santa Ana wind scenario or something. And you can model that specific scenario with Flam Map to enhance and complement your risk assessment work. We did not do that for this project because we're just leaning on the national scale FSIM stuff. And Frank mentioned FS Pro. That is a more of a sort of incident specific, take a fire that's currently burning and look at the probabilities of how it might grow in the next 7 to 14 to 21 days. So.
You got one, Kelly?
I sure do, yeah. There were a couple of questions about the vulnerable populations data set that we use, and I might be able to just respond to that quickly, and then I'll pitch another question for Greg. The vulnerable populations data that we used are based on US Census data, and we selected some indicators that are available nationally through the American Community Survey. There are a lot of other indicators about community vulnerabilities in terms of health and social and economic factors. And we used data that were simply consistent and nationally available. There were some other questions about whether that data is available for download, and if folks have questions or want access to that data, please don't hesitate to get in touch with me and I can help you gain access to that data. That is an enhancement we're looking at for a future improvement to the Wildfire Risk to Communities website. And then there was also just a technical question, and I wanted to just point out that it's important to use the website in Chrome or Firefox or Edge or another modern browser. It's not supported in Internet Explorer. So please be sure to use it in one of those browsers. And Greg, there were a few questions about Embers and the exposure layer. There were some questions about if you could provide a little bit more clarity around whether landscaping and homes were considered as fuel sources and how airborne embers are considered in the risk to homes layer as opposed to just the exposure layer.
Sure. Yeah, I mean, embers are pardon the pun, a hot topic. So everybody wants us to be able to accurately map, where embers might go under different scenarios. The science behind actually accurately modeling ember production, ember transport is incredibly complicated, and there are folks working toward that. There are elements of it that I know Mark Finney, I've talked to him about this at length, and he'll say there are things about it like the numbers of embers that might be produced under different scenarios is totally unknowable. There are things that we can know about how far maybe they can transport under different wind conditions and things like that. So for what we did, the answer is no. We did not incorporate any science related to Ember transport. We didn't account for landscaping around homes when we, spread stuff into the community. We're simply trying to address what we know is a shortcoming of the national fire modeling data in that, developed areas are mapped as non-burnable. We're trying to address that right now just with a technical GIS solution to use focal analysis and spread those pixel values in GIS analysis world. There are ways that Pyrologics is starting in some of their current analyses to incorporate more of a built environment fuel model and actually let the fire spread, but even that is still a guess. And so we're a long way off from accurate Ember modeling.
Great. Would you just add to that a little bit about vulnerable buildings? That was another question that came up. Just were we able to account for individual building vulnerability?
Yeah, sure. No. That was addressed with the response function when I talked about the fact that, we really just had to make that broad generalization across the entire landscape to give us a relative metric of home risk. You could think of it really as hazard. We're just bringing that response function element in to try and address the susceptibility piece, but no, we don't have any way to address the vulnerability or susceptibility of specific homes. That's something that people can do at a more localized scale.
But yeah, this analysis could be a start for a community to do that kind of analysis at the local scale. I had one technical question, Greg, about the conditional flame length and the average weather conditions. From California, I think they said that they used the 95 percentile. Is that what we used, or did we go somewhere else?
No, and so that gets back to the idea of FSIM being an ensemble model, and so it's really going to average wildfire occurrence across all range of conditions that will allow fire spread. So I think in the FSIM model, if you're below the 80th percentile ERC, fire doesn't spread. So you can consider it a sort of a conglomeration of possible scenarios at everything above that threshold, but it's not specifically at the 95th percentile.
I'll go again if Kelly doesn't have another. A question about LandScan data. They asked if we use the day and the night version. I wasn't aware that there's two kinds of LandScan.
There are, yes. I think we did. Pyrologics did that processing, but yes, I think they incorporated both the daytime and nighttime into their housing unit density. And really, I didn't mention this detail, but what we get from LandScan or from any other way of trying to get at density is a population estimate. So number of people, but we wanted to put that in terms of number of homes. And so we use a conversion factor to convert from a population density number over to, an average number of people per house to get us a housing density.
And then on the question and answer page, Mark has a question about what does the model say about some recent major fires, like the Camp Fire, the Tubbs? Obviously, those are too new to be included in the fuels data set, but I think they did come up as a high risk area.
They did. I think WHP in particular, there was that article in USA Today last summer where they actually evaluated that exact question. They looked at the wildfire hazard potential rating for the community of Paradise, California, and then compared that to communities across the West, I think, to see which communities had similar or higher levels of hazard from that WHP map as Paradise. I was actually just looking at Paradise for another little webinar I did the other day in our tool, and for risk to homes, Paradise, California comes out at the 63rd percentile among communities in the state of California. And so that tells you that while it had a decent amount of risk, there are 35% of communities in the state of California, according to our mapping, have higher risk than Paradise did. So a lot of it is just, that's why this is probabilistic, and the actual realization of those probabilities is, a real sort of stochastic thing in terms of alignment of all the right factors of ignition and weather, or you could say all the wrong factors. But
Kelly?
Yeah, just one last point. There was a question about buildings other than homes. You know, were we able to incorporate and address things like hospitals, assisted living centers, or other kinds of structures?
That's a really good question. So with this, we specifically did, or I say we, it's really Pyrologics that did the work. We did try to single out homes, so places that are actual residences, and exclude things that were strictly commercial buildings. Now, things like nursing homes, university dorms, military barracks, all those kinds of things are really tricky when it comes to that. Pyrologics, I can tell you, is one of the, they're some of the most thorough people I've ever worked with. And so they've really worked hard to try to make those numbers just where people live.
Just a final reminder to have folks please take our evaluation poll that's up on your screen right now. Is there any other questions that Frank or Kelly you want to address that didn't get answered? I see one that just came in and I can't read it that fast, so I'll let maybe one of you guys take a stab at it. Just a reminder that the PDF of this talk and last week's talk will be available on the WRC website. And this recording will be available on our YouTube page, our Landfire YouTube page. So I'll put the link in the chat window if you want to grab that, and you'll be able to access it whenever you want.
I would just add one final comment before we close, and that is that we are actively working to improve the site. And so we really value your feedback and input. Please don't hesitate to get in touch with us if we weren't able to answer your questions today, or if you have suggestions for us.
Great.
I do, if we have a second, I see a question from Andres Schmidt that just came in. And he raises a good point. He says, you know, we use spatial interpolation to assign fire model results to built up locations. And wouldn't it be safer to just say that we don't have data there and we can't provide results? And that's kind of what we've done in previous projects up until now. I've had the opportunity to work on community level assessments and broader scale. And the problem that ends up happening is people look at the maps and they see 0 burn probability, 0 hazard, 0 intensity for places along the fringe of communities where they know that wildfire risk and hazard exists. And so our approach here was to try and acknowledge that, if even in a crude way. And we were fairly conservative in how we did that, but we felt like to not address it, to not try and show that you have some degree of exposure of homes in that fringe of a community was, you know, maybe we didn't want to err in that direction.
Great. Well, that seems like a good place for us to wrap up today. Once again, thank you, Greg and Frank and Kelly, for taking the time out of your schedules, and thank you to all of our attendees for joining us today. It's been enlightening, and I've really enjoyed hearing about this awesome project that, yeah, is hopefully going to help a lot of people. So everybody have a wonderful day, and with that, I'll say goodbye.
Thanks, Megan.